So, in the computer architecture lectures, we have seen the basic structure of a processor, and we have seen the basic components that should be there in any processor. Now, from today onwards, we will be looking into the 8085 microprocessor, which is one of the I should say the basic microprocessors that we should be familiar with to understand this whole course of microprocessors, microcontrollers. So, you can say that for all other processors, the basic idea came out from this processor design. So, that is why this makes a very good example to study any course on microprocessors. Of course, there are many advanced microprocessors today, but 8085 should be chosen as the base, because the concepts introduced there have gone a long way in manipulating the ways in which the new processors are designed. So, we will first look into this processor design. So, what is microprocessor? So, if we just try to answer this question, so we will try to differentiate between three terms: microcomputer, microprocessor and microcontroller. So, these terms are many times they come to our mind, and we also see them in the literature, and we should know the difference between them very clearly. A microcomputer is a computer with a microprocessor as its CPU. So, any computer that has got a microprocessor as its central processing unit is a microcomputer. So, it has got its own memory and input output devices that should be connected. So, to make the complete computer system, we should have the additional components in it. So, as we know that for microprocessor we have for any computer, any computer system, we have the basic CPU, and then we have got this memory, and we have got the IO devices. So, this when we talk so this CPU, when this CPU is a microprocessor, then we will call it a microcomputer. So, apart from that, the IO devices and the memory, they should be connected to make the system complete. So, microprocessor, what is it? So, it is a silicon chip which includes ALU, register circuits and control circuits. So, in our lectures on CPU design, so we have seen that a CPU consists of essentially one arithmetic logic unit for doing the arithmetic logic operations. Then there is a register bank to hold these intermediary values, and many a times the operands are taken from these registers by the CPU, by the ALU, and there is a control logic which controls the overall operation. Now, in older days, these when these computers were being designed, this processor design was partitioned into designing these individual components separately. So, this separate ALU design, separate register circuits, register design, separate control logic design. So, that way it made something called a bit sliced processor. So, we call it a bit sliced processor. This was called a bit sliced processor, as if the design is in terms of say 4 bit ALU, 4 bit registers like that, and then we are getting the corresponding circuit done, and if you need say 8 bit register, you take two such 4 bit designs, combine them to get 8 bit. Similarly, if you are looking into ALU design, so basic ALU design is of 4 bit ALU. So, if you want to go for higher sized ALU design, so you have to club these ALU slices to get the 8 bit slice or 16 bit slice that way. So, there it was bit slice designs, but the problem with this type of design is that you have got these separate modules, and those chips are going to be separate. So, ALU is a separate chip, register each register may be a separate chip like that, and you know that when all these are integrated on a printed circuit board, so they are connected externally by means of copper lines. So, the speed of the system is limited by this speed of this external line. So, you cannot achieve very high speed with this type of designs. So, for the high speed design, so what is required is that all these components within the CPU, they should be contained in a single chip. So, when we talk about microprocessor, they are essentially doing that. So, all these components they are designed in a single chip. So, it is a single silicon chip which has got ALU, registers and control circuitry. Then in the later part of this course we will introduce microcontroller. So, it is actually one step ahead, particularly when we are thinking about designing say embedded applications like say cell phone or say a telephone handset or say refrigerator. So, that way or say digital camera. So, what happens is that we want to go for miniaturized modules for them, like nobody will like a cell phone which is quite large in size. Okay. So, that way we want that to be smaller and smaller, only the screen we want to be larger, rest of the circuit they should be small. Now, how to make this small? Like that in a printed circuit board, if you put a large number of components like the processor, memory, IO separately, then that is going to take a good amount of space. So, to reduce the space requirement, what is done is this entire computer is made on a single chip. So, when we are talking about this IO, CPU and memory, so they are made part of the same chip. So, they are made part of the same chip. So, when you say this, so this becomes this memory, IO and CPU. So, they are put into a single chip, and as a result what you get is a microcontroller. So, they are very much they have become more popular when we have gone for this embedded system applications. So, they are becoming more useful. So, if we are if we go by the definition, like what about the micro? So, why micro? Why not simple processor? So, micro is a new addition. Okay. So, this the word microprocessor, it comes from the combination of two words, the word micro and the word processor. So, processor, we know that it is a device that processes whatever, like so whatever data is given, so it will do some processing on that. So, processor is a device that processes numbers, specifically binary numbers. When we are talking about electronic circuit, it is a processing of binary numbers, zeros and ones. So, processing means to manipulate the numbers. So, whenever a device is doing those manipulations, so that is a processor. So, when we are electronics engineers, so we will be talking in terms of electronic circuitry. So, we will be talking about the electronic component which does this processing. So, they will be called processor. So, it is basically describing all type of manipulation. So, certain operations will be performed on the processor, and what are the operations that we can do on these numbers, that is defined by the microprocessor design team. So, they actually have told like what are the operations that you can do with the data set in this microprocessor. So, accordingly that microprocessor will be able to do those operations only. Similarly, if that is true for any other processor design, of course, not only specific for microprocessor. Now, so processor part we understand in the term microprocessor, but what about the micro term? So, micro, so it is in late 1960s. So, processors were built with discrete elements. So, just some time back I was talking about it, that you take discrete elements, like you take the ALU separately, you take the registers separately. So, that way we combine them together into something, and that into one design, and that way we get the processor. So, that way these devices were performed to perform the required operation, but were too large and too slow. So, that naturally their footprint will be large. So, as a result the resulting circuitry or the design the device that we have, so that will be larger in size. So, nobody will like that, and you can easily compare the electronic components that we had in 1960s and the electronic appliances that we have now. So, size there is a huge difference, and not only size, the power consumption, performance, everywhere it is improving. And one basic reason for this improvement is that we could miniaturize the whole system, and we could put this the design into a single chip. So, in 1970s the microchip was invented, and all the components that made up the processor are now placed on a single piece of silicon. So, the size becomes smaller and speed become much larger, much faster. So, that way the microprocessor was born. Processor was there, and with the invention of this microchip, then these microprocessors came into existence. It essentially raises a question like, was there any mini processor somewhere? So, processor, mini processor, microprocessor, can it be like this? Well, the answer is no. It directly went from discrete elements to a single chip. So, there was no intermediary point in between. However, you can say that comparing today's microprocessor to the ones built in 1970s, so you can find an extreme increase in the amount of integration. So, that way you can say that something was mini processor. So, if you like, but as such in the technology there is no such term called mini processor, though there is mini computer which was which was smaller than mainframes. So, that way mini computers are there, but mini processor there is no such concept. So, what is a microprocessor? So, if we try to answer this question, so a microprocessor, if you define into a layman, so you can say that it is a programmable device that takes in numbers, performs on them arithmetic and logical operations according to the program stored in the memory, and then produces other numbers as a result. So, this is the overall operation of the microprocessor without going into the design part of it. So, we will go by these individual terms like programmable device takes in what is the input it is taking, what sort of operations it can perform, and on what it can do the perform. So, one is the type of operation, and another thing is on which, what are the operands on which it will do the operation, and finally, what is the result that it produces. So, we will try to answer all these when we go into the definition of microprocessor. So, first term that we have is a programmable device. So, this is the best thing, like if I am asked to design some circuit, so I can design the circuit which will do that operation only. For example, if I am asked to design a circuit that will scan one input bit stream, and whenever it finds the pattern 4 ones followed by a 0, so it will output a 1, otherwise the output bit is 0. So, if we design this circuit by means of some flip flops and gates and all that from our classes in digital logic, we can so that circuit will be able to do that operation, but it is dedicated for doing that operation only. So, programmability is not there, it is dedicated for that particular application. So, microprocessors on the other hand, so they are programmable device. So, they can perform different sets of operations on the data it receives depending on the sequence of instructions supplied in the given program. So, microprocessors, they are guided by the instructions. So, all the microprocessors, they will have a reset pin, and if you reset that microprocessor, so it will start looking into the memory from a fixed address, and from that address it will expect that there will be an instruction in that address. So, it will take that instruction, execute it, then it will upgrade its program counter type of register, so that it points to the next instruction, and that way it will go on. Now, if there is no valid instruction at a certain memory location, then what the microprocessor will do? So, that is not defined. In fact, that depends on the way the microprocessor has been designed. So, so at the beginning of every such cycle, what the processor will do, it will try to get the next instruction from the memory, and if that instruction is not meaningful to the processor, then some exception situation will occur, and how that exception will be handled. So, that is defined by the designers of the microprocessors. But anyway, assuming that there is no such erroneous cases, so we have got microprocessor getting correct instructions and executing them. So, today maybe I have a microprocessor that scans the temperature of a room, and accordingly monitors the temperature of a room, and that way it first reads the values from the sensors, temperature sensors, then it turns on say ACs or heaters depending upon the set temperature value and the deviation from that. So, if tomorrow you want that same microprocessor to do something else, not the temperature monitoring, but maybe say a conveyor belt monitoring or conveyor belt control operation application. So, in that case the microprocessors, the program part needs to be changed, and the microprocessor will remain same, only the program that it was executing will change. So, in the memory now you have a different program, so that the microprocessor will do something else. So, that is what a programmable part. So, you can change the program part to get some other job done by the microprocessor, which is not possible by any arbitrary digital circuit. Then the instructions, second part is the instructions. So, each microprocessor is designed to execute a specific group of instructions, a specific group of operations. So, this is called an instruction set. So, if you look into any microprocessor, the first thing that you should do is to look into the user manual, and the user manual, so it will be detailed like what are the instructions that this processor will support, and while writing programs, so we should write following those instructions only. And many times, so we do not know all these things, because we write our programs in some high level language, and then like say C or Java or C++, something like that, and after that there will be a compiler. The compiler will compile the program and it will translate it into the language that is known by the underlying processor. So, if today you are running your C program on a computer system that has got 8085 as the basic processor, so this compiler will should generate the code which is understandable by the 8085 processor. So, the instructions that is understood by 8085. Tomorrow, if it is some other system on which you have got the same program to be executed, but say the underlying processor is different. So, it is say ARM processor. In that case, the compiler that you should have there, so the compiler should be translating the program into the language which is understandable, or the instructions that are understandable by the ARM processor. So, that way microprocessor will finally understand a set of machine instructions, and that is told, that is fixed by the designer of the microprocessor. So, that is not in the hand of the user. So, user has to write the program using those instructions that are available. So, next part is the takes in. So, what is the value that it takes in? So, I said that it does some manipulation on the data that it takes. So, it can come from the input devices, like I can have a number of peripheral devices connected to the microprocessors. So, we have seen that any processor can be connected to the memory as well as it can be connected to the I/O devices. So, memory can also be treated as an input device if you note down the input values for a program in the memory itself. For example, if the job is to sort say 100 numbers, and in the memory itself I store the 100 numbers. So, what the processor will do? It will operate on those 100 numbers stored in the memory. On the other hand, if it is like this, that I have got a temperature sensor installed, and while operating, so the system we should take temperature from that temperature sensor. So, in that case it is the coming from the input device, which is the temperature sensor. So, this way it will go on. Okay. So, that way, so input devices it may vary, and the input come from the input devices. So, these are the devices that bring data into the system from the outside world. So, this is the interface to the outside world, and the problem is that the outside world is in general analog in nature. So, though we are designing digital circuits or the microprocessors, they are operating with digital data, the outside world is analog in nature. So, accepting some very simplistic type of inputs, like say switch, a particular switch, whether it is on or off, a particular light, whether it is on or off. So, accepting this type of input, so what you have is a continuous data. So, for example, if I say this temperature sensing, so temperature sensor, so it will generate a range of voltages depending on the temperature that it is getting. So, it is not a digital one. So, many times what happens is that from the input device to the processor, so in between we have some sort of data converters, and some of the processors are equipped with those data converters. like analog to digital conversion for the input part and digital to analog conversion for the output part. So that the processor handles digital data only, but it can talk to the outside analog world through these two ADC and DAC converters. No, so what is happening is that these devices, they bring data into the system from the outside world, and there can be devices like keyboard, mouse, switch. So, all these they can be treated as input device. Next part is the numbers, like how are the numbers manipulated, okay? Like what are so what are the values that it can have. So, while we are talking to our this universe, so these numbers are can be very large. So for example, if I talk about integer numbers, say, so integer number, it can have values up to infinity, it can be arbitrarily large. But what happens is that when you are putting it inside a computer, a number, so this you cannot give infinite storage to store the number. So, there will be a finite size. So, that way in some sense I can say that the microprocessor has a very narrow view of life. So, integer, if you are dedicating say 16-bit to it, so if you are considering both signed and unsigned integers, then it can go from -32768 to +32767. So, that way there is a range. So, so that way the microprocessor, it has got a very narrow view of life, we can say, and it only understands binary numbers. So, only zeros and ones, not the octal, hexadecimal, integers like that, though for our own understanding many a times we even represent binary numbers using these octal and hexadecimal notations, but inside the processor it is always the binary number system that works. And a binary digit, which is also called bit, so that is how the numbers are stored, because this bit 1 is stored as a high voltage value, or somehow this is taken as logic level high, and 0 represents the logic level low. Now, a microprocessor recognizes and processes a group of bits together, which is the group of bits is called a word. So, like if I am working with some two integers, so this integer, what is the size of the integer, or when I am getting an instruction, this instruction that the processor can handle, so it should have a finite size. So, what happens is that this processor, it always talks in terms of words, is a collection of bits. So, a word may be consisting of say 16-bit, a word may consist of 32-bit. So, that way it can consist of number of bits that is fixed by the designers, but when it is doing the basic operations like addition, subtraction, multiplication, division, comparison, okay, so all these operations, then they are operating at the word level. So, this is fixed by the processor designer, what is the word size for the processor. So, for the microprocessor also that is same. The number of bits in a microprocessor word is a measure of its abilities. So, why do we say this? So, when I say a microprocessor is an 8-bit microprocessor, so it means that it can operate on 8-bit values. So, when I am doing addition, so I have to keep in the integer addition, so it will be only 8-bit numbers, and the result can be 8-bit plus 1-bit carry, total 9-bit. Or so if I am talking about powerful processor, that means it will be able to handle larger values. The difficulty is that if you are having smaller sized numbers, then in a basic step the processor will be able to do operation on those smaller sized data. So, if the basic processor is supporting say 8-bit addition, and now I am interested to do a 16-bit addition, I have to implement in software this 16-bit addition in terms of 8-bit additions. So, I am not saying that this is not possible, but this will take more time compared to the case in which a processor handles 16-bit word, and that 16-bit addition is done in a single shot. So, that way we can have the difference between this microprocessor capabilities. So, today the microprocessors that we have, so 8085 is 8-bit word, but if you look into today's microprocessors, so they are having 32-bit, 64-bit word size. So, that way it can handle much larger data. So, words, bytes, etc. So, the earliest microprocessors, they recognized 8-bit words. So, 8085, 8088 and this Motorola 6800, 6800. So, they are all, they handle 8-bit words. So, processors like 8086 and 68000, they were designed as 16-bit word. Now, there is a small thing to notice here, that Intel 8086 and this number is 8088. So, why this 8088 being coming later, as the name suggests. So, this processor came later than this 8086, but why this is 8-bit and 8086 is 16-bit. Okay. The reason is like this, that 8085 came before all these 8086 and 8088, and it was very popular. It was a very popular processor, and then many systems were developed using 8085. Okay. And 8085, it has got 8-bit word. So, this the number of pins, the data lines that comes out of the processor, so that was 8-bit. Now, tomorrow when this 8086 was introduced into the market, so you cannot just take out this 8085 chip and put the 8086 chip there, because of the simple reason that the data bus size itself got changed. So, from 8-bit, so it has become 16-bit. So, it becomes, the hardware becomes incompatible. So, after understanding this thing, what Intel did is that they just went one step back and make 8088 one 8-bit processor, though its internal operation is exactly similar as 8086, but from the outside world. So, it is an 8-bit or 8-bit word interface. So, all the systems in which 8085 was being used, so they can be replaced by this 8088 processor, and the hardware remains unchanged. Okay. So, this, of course, the software has to be changed, because that will be now for 8088, but the hardware part do not need to change. So, these microprocessors, we had 16-bit word, a group of 8 bits, we call it a half word or a byte. So, a word is, if we call a word to be 16-bit, of course, there is no standardization, standard thing like this 16-bit word. So, you can have some processor with 32-bit word, 64-bit word, whereas byte is a very standard term. So, 8 bits constitute a byte, but this word size is dependent on the processor. So, if we say that word size is 16-bit, then the group of 8 bits they are referred to half word or byte. Group of 4 bits is called a nibble. So, if you divide the byte into two 4-bit parts, so each of them will be called a nibble. So, 32-bit groups, so they are often named as long word. Of course, again the same thing. So, this is a bit non-standard, because it depends on the word size of the processor. And all processors today, they manipulate at least 32 bits at a time, and there exist microprocessors that can process 64, 80 or 128 bits also. That way, we can have much larger capability wise much better processors, in which we can manipulate larger data width in a single instruction.